We are from Group 12 who will be presenting on oil processing via ultrasonic treatment. Introduction. What is ultrasound? Ultrasound basically is cyclic sound pressure wave with a frequency greater than the upper limit of the human hearing range. It operates with frequencies from 20 kHz up to several GHz. And what is oil processing? Oil or petroleum, basically the main raw material in the production of chemical products such as plastic, pesticide, pharmaceutical, and many more. Petroleum consists of hydrocarbon chains in their chemical structure and at different lengths. Hydrogen and carbon are two main atoms involved in hydrocarbon chain, which are come in straight branching chain to ring. Numbers type of process to separate the petroleum to be used in variety of purposes. One of the process was distillation. Distillation is the process which several of product will be produced such as gasoline, kerosene, fuel, and bitumen at different temperature depend on its boiling point. So, problem statement. Basically, our problem statement is to study on how the ultrasonic treatment be used in oil processing. From distillation, emulsion can happen. Emulsion happens when there is water present in crude oil reservoir or was injected as steam to stimulate oil production. Formation of water and oil emulsions is really unwanted phenomenon in petroleum industry. This problem can be reduced by several methods of demulsification. And one of the process was demulsification by ultrasonic treatment. Ultrasonic energy will be used in order to enhance the breakup of water in oil emulsion. Under the induce of ultrasonic field, the smaller droplet in the emulsion could move faster than the larger droplet because of the smaller drag forces acting on them. The collision frequency with larger droplet will increase as the movement of smaller droplet faster. By ultrasonic treatment also, there will be advantages in the crude oil upgrading. With uses of high power ultrasound, it can accelerate the sulfur compound oxidation needed to upgrade crude oils and petroleum products into sweeter crude and products, potentially eliminating or reducing the need for hydrotreating. Technology works by taking the sulfur chemically bound to some of the molecules in the oil and oxidizing it using hydrogen peroxide together with the ultrasound.
Hi, I'm Geraldine. I'm going to present on process description in oil processing via ultrasound. Ultrasonics with oxidation chemistry is used to improve the quality of crude oil and crude oil fractions. High-powered ultrasound can significantly accelerate the sulfur compound oxidation needed to upgrade crude oils and petroleum products into sweeter, which is containing less sulfur, crudes and products such as diesel. Taking the sulfur chemically bound to some of the molecules in the oil and oxidizing it using hydrogen peroxide, a classic oxidant, together with the ultrasound. On a molecular level, the hydroxide peroxide donates one of its two oxygen atoms to the sulfur to form water as a byproduct. The treated oil typically has less sulfur, lower viscosity, and higher API gravity. For the process, in operation, the oil, hydrogen peroxide solution, and catalyst are introduced into a reactor, where very intense mixing happens in the cavitation zone generated by the ultrasound. The water and oil separate, with the water subsequently being recycled and new hydrogen peroxide added to offset that use in what is more or less a closed-loop system. Then the cavitation induced as oil and additive stream through the reactor and past the ultrasonic probe leads to the creation of bubbles at the site of the refraction owing to the tearing of the liquid caused by the negative pressure of the intense sound waves. The bubbles then oscillate under the effect of positive pressure, growing to an unstable size as the wave fronts pass. The bubbles eventually burst, generating excess heat and pressure in and around every micrometer as sub-micrometer size bubble. This happens in a matter of nanoseconds, and each bubble behaves as a microreactor, accelerating the chemical reaction described earlier owing to the heat release and localized pressures obtained. Free radicals form as a result of the breaking of molecular bonds in the water vapor at the thermolic center of the cavitation bubbles. While a large portion of these free radicals rapidly reform into water vapor, a few bring about the displacement of sulfur in the hydrocarbons. It also results in cracking the bonds of residuum elements, thereby enhancing the crude quality. The transfer of hydrogen from water to the numerous petroleum streams lead to the removal of sulfur from the crude oil present in these streams.
I'm Tong Fu. Now I'm going to talk about the ultrasonic equipment. For the ultrasonic equipment, there are two technologies selected by our group. The first one is the bubble horn ultrasonic technology by the Industrial Sonomechanic, or so-called ISM company. And the second one is the Heschel ultrasound technology by the Heschel group. The first one, the bubble horn ultrasonic technology. The industry sonomechanic offer bench and industrial scale ultrasonic liquid processor, also known as ultrasonic homogenizer and sonochemical reactor, able to provide very high ultrasonic amplitude and cavitation intensity. Application example include production of nanoemulsion, nanocrystal and wax nanoparticles for pharmaceutical, cosmetic, food, ink, pen, coating, wood treatment, metalworking, nanocomposite, pesticide, and few industries such as oil processing. There are two types of equipment used. The first one is the BSP 1200 bench scale processor. The BSP 1200 bench scale ultrasonic liquid processor is designed for batch and flow-through process investigation and small-scale production. The system operates at the frequency of approximately 20 kHz. For the ISP 3000, the industry scale processor is designed for high volume commercial production. The processor output up to 3000 watts of acoustic power into a working liquid and operate at a frequency of approximately 20 kHz. The second company is the Heschel ultrasound technology. The first type is the UIP 1000 HD powerful and versatile homogenizer. The UIP 1000 HD is a powerful and adaptable ultrasonic device for lab testing and industrial processing of liquid. It is used for applications such as emulsifying, dispersing, and particle fine milling, lysis and extraction or homogenizing. The second type is the UIP 4000 high ultrasonic output power. The UIP 4000 is used mainly for the industrial processing of liquid, such as homogenizing, dispersing, disintegrating, or deagglomerating. The powerful ultrasonic processor UIP 4000 is used when high power is needed for continuous operation. It is controlled by a microprocessor and equipped with an LCD status display as well as with an interface for external control signal. The third one is the UIP 16000, the most powerful ultrasonic processor. 16,000 watt of ultrasonic power made the UIP 16000 the most powerful ultrasonic processor in the world. It is designed to work in cluster of 3 or more units for large volume processing, such as to homogenize, disperse, or deagglomerate. There are 3 types of ultrasonic setup. The first one is the ultrasonication in single pass. The second one is the ultrasonication in continuous recirculation, and the last one is the ultrasonication in discrete recirculation.
I'm Leo Wei-Jian, and I'm going to present about the advantages of ultrasonic in oil processing.
The advantages of ultrasonic treatment in oil drilling process has benefit the clear consumption by decreasing 30% when ultrasonic treatment is used. Besides that, ultrasonic processor can reduce the drill's cutting sizes and thus eliminate the power of cutting off that will contaminate and harm the marine habits. Next is the advantages of ultrasonic treatment in emulsified wax from oil. By using ultrasonic, the ultrasonic pressure wave can generate from a fluid resonator and is very effective in emulsifying oil-water wax. Besides that, the bar hole wax can also be removed from the ultrasonic treatment. Next is the advantages of ultrasonic treatment in separate of oil from the tar sands. By using ultrasonic treatment, it can enhance the limiting stage of separation by the conventional method, and the ultrasonic wave can enable to penetrate into different regions which cannot be done by the other separation method. Besides that, the total extraction rate can be increased 3 times faster when using ultrasonic, and the extraction of coal can be extracted more when using ultrasonic. And it has a higher efficiency for extraction process when using ultrasonic when extracting for the oil from the tar sands, which can be increased from very high from 90% and produce relative fuel and environmental acceptable emissions. Next is the advantages of ultrasonic treatment in recovery of bitumen. Bitumen can be recovered from ultrasonic treatment with a very low ash content and free of metal and aspartanes. The recovered bitumen is recovered by using ultrasonic has a very higher API gravity and higher CH ratio. And the advantages of ultrasonic treatments in oil desulfurization process can be used for accelerate the sulfur compound oxidations and upgrade the crude oil and petroleum product with less sulfur contents crude and product. And ultrasonic can be used for eliminate the need for hydrotreating, and this could be reduce the undesired chemical side reactions and increase the purity of the product, save up the expenses, and most important is does not cause environmental pollution. Next is the advantages of ultrasonic treatment in coal treatment process. Ultrasonic treatment of coal can be increase the surface area extractability of the coal. So ultrasonic agitation is more efficient than mechanical rotation, and by using ultrasonic is more effective and more economical by the conventional method.
Hi, I'm Farhan and I'm presenting about the application of ultrasonic treatment in the oil industry.
There are 2 applications of ultrasonic treatment in oil processing, which is desulfurization and oil recovery. First one is desulfurization. Ultrasonic treatment in oil processing does help removing sulfur in crude oil. As we know, removing sulfur helps improve the quality of the processed oil and also the fraction of oil too. Usage of ultrasonic treatment has potentially eliminating or reducing the need of hydrotreater in the crude oil process. The technology works by taking the sulfur, chemically bound to some of the molecules in the oil, and oxidizing it using hydrogen peroxide, a classic oxidant, together with the ultrasound. On a molecular level, the hydrogen peroxide donates one of its two oxygen atoms to the sulfur to form the water as the byproduct. The treated oil typically has less sulfur, lower viscosity, and higher API gravity. In addition, remaining sulfur is thereby converted into a different sulfur species that can be more easily separated. In operation, the oil, hydrogen peroxide solution, and catalyst are introduced into a reactor where very intense mixing happens in the cavitation zone generated by the ultrasound. The reaction takes place in a half second or less. The water and oil separate, with the water subsequently being recycled and the new hydrogen peroxide added to offset that use in what is more or less a closed system. The second one is the oil recovery from refinery oil sludge. Oil sludge is the waste disposed after the crude oil processing, and it is known that the disposal of the waste has received increasing concerns, and one of the possible solutions is to recover the oil from the sludge. There are some research that shown ultrasonic treatment can recover the oil combined with the freeze-thaw treatment. Recovery rate of oil in the sludge can go up until 80% by using combined process just now by using ratio of sludge water of 1:2 and without the addition of biosurfactant and salt.